So these are 7.5 notes. Apply the tangent ratio. Okay, so you for sure need a calculator that has the sine, cosine, tangent buttons for this lesson. So make sure you have those because we are going to be using those buttons today. Okay, so tangent. So these are trig functions. Trig functions are a ratio that helps us to find angle measures and or side lengths. So the thing that I need for you to remember, a saying, is so, ka, toa. And today we're going to be working with the toa part. Okay? So what this does, tangent ratio. Let triangle ABC, this triangle over here, be a right triangle with acute angle A. The tangent of A is written as the length of the leg opposite A over the length of the leg adjacent to A. Okay? So we're going to take that information, we're going to work with it. Once you work with it, it's going to make a little bit more sense. First off. Okay. So find the tangent of A and tangent of B. Write each answer as a decimal rounded to four places. So we're going to find the tangent of A. So you're going to circle A. Okay. So now tangent is O over A. O stands for opposite over A, which is adjacent. So if I circle angle A up here, we were talking about A, it's the leg opposite over adjacent. So on a right triangle, whenever you talk about an angle, you have an adjacent side, you have an opposite side, and then you have an H, hypotenuse side. We don't use the H in tangent. We use the H in sine and cosine, okay? Because there's that H and there's that H. Here we use opposite and adjacent. So what I'm going to do is I'm going to think about, okay, TOA, T-O-A, O is opposite, so opposite comes first. So the side opposite A is 45, so I'm going to write down 45 here. The side adjacent to the A is 28. The reason it's not the 53 is because that is my hypotenuse. Okay, we don't want the hypotenuse. We want the adjacent side that's not the hypotenuse, so that's 28. So all they're wanting on these problems is for you to put that 45 over 28 into your calculator, so 45 divided by 28. They want it rounded to 4 decimals, so that equals 1.6071. And that is the decimal equivalent of that ratio. Now, tangent of B, so I'm circling B. These letters only work for A, because on B, this 45 is adjacent, this 28 is opposite. Now the H still will always be H because it's always the hypotenuse. So tangent of B is TOA, so we went tangent, so opposite over adjacent. So opposite of B is this 28 over adjacent, which would be 45 in this situation. So I'm going to do 28 divided by 45, which I get 0.6222. That 2 is repeating actually, so rounded is just stays 2. Go ahead and pause me and try 2 and 3 on your own. So I'm going to circle B. I'm going to write my letters. This is adjacent, opposite, hypotenuse. I went tangent, so TOA. So opposite, which is 33. Oops, we're on B. 33 over adjacent, which is 56. So 33 divided by 56, 0.5893. Tangent of A. Here we have adjacent, opposite, and hypotenuse. Tangent would be TOA, so that would be 56 over 33. If you notice, these are just inverses of each other, right? Or the reciprocal of each other. Would be a better word. That is 1.69. That actually rounds to 70 because it's 696. And so that 6 rounds that 9 up. One more. So I'm going to circle A with the brown pen. This is adjacent, opposite, and hypotenuse. So we're still doing tangent, so we're still doing TOA, so it's opposite 9 over adjacent 12. 9 divided by 12, we should know that, 0.75. And then blue, this is adjacent, this is opposite, and that's still hypotenuse. So opposite is 12 over 9. 1.3 repeating, so rounded to the nearest fourth decimal would be that guy. Okay, so now coming down here, Find the value of x to the nearest tenth. So what these trig ratios allow you to do is, in Pythagorean theorem, we took right triangles. I gave you 2 side lengths, and you could find the third side length. But now what we have is we have a right triangle with only 1 side length. You can use these trig ratios, sine, cosine, and tangent, to find another or the other 2 side lengths given only 1 side length. You do have to be given an angle measure though, okay? So you are always going to circle your angle measure, and you're going to label all your sides. So this one is adjacent, this one is opposite, and this one is hypotenuse. So we're in the tangent section. So on all these, you're going to be using TOA. So how you're going to write this is you're going to write tangent of 43. So you're actually going to write the tangent of the angle measure is equal to, now it's TOA, so it's opposite comes on top over adjacent on bottom. And what you're going to do is you're actually going to write this like a proportion. So you're going to put this over 1 so you have a top and bottom, top and bottom. And then you're going to cross multiply. 1 times 29 is 29 equals x times tangent of 43 is just x times the tangent of 43. There's nothing else you can do on that. Our goal here is to find the side length x. So in order to do that, I have to get x by itself. So just like you're solving something else, you have to divide, since those 2 things are multiplying. You need to divide by the tangent of 43 on both sides. So this cancels. So I get x equals 29 over the tangent of 43. That is what you're going to put into your calculator. You're going to do 29 divided by tangent, brings up parentheses, 43 in parentheses, press enter. And you get x equals, it says nearest tenth, so 31.1. What that means is that this length right here is 31.1. Now, if I then wanted you to find this length, you have 2 side lengths, so you could use Pythagorean theorem, a squared plus b squared equals c squared, to find that third side length. Or, once we learn all the trig ratios, you could use a different trig ratio to find this h. It wouldn't matter. Let's try number 5. Circle the angle that they gave you, label all your sides. So x is adjacent, 9 is opposite, and this is my hypotenuse. So we are using the O and the A, so that must be TOA. So we do tangent of 24 equals O, which is 9, over x, which is A. Put this over 1, and we're going to cross multiply. So we get 9 equals x times the tangent of 24. Again, our goal is to get x by itself, so I need to divide by a tangent of 24 on both sides. This cancels, so I get 9 divided by tangent of 24. And I get x equals 20.2. So this side length is 20.2. Should make sense. It should be longer than this guy, so that's good. All right. Try 6. Pause me. Try 6 on your own. Unpause me when you're done. Circle the angle measure. This is adjacent. This is opposite. This is hypotenuse. So we're using letters and numbers on the O and the A, so that would be tangent. So tangent of 41 is equal to TOA, so opposite is x over A, which is 16. Put this over 1. Cross multiply, and I get x equals 16 times the tangent of 41. On this one, we actually have one less step, because the way that we cross multiplied allowed us to have x by itself to start with. So all we have to do is do 16 times the tangent of 41 on the calculator, and I get x equals 13.9. Okay, pause me, try 7, 8, and 9 on your own. Unpause me when you're done. Circle that angle. This is adjacent, this is opposite. It has to be TOA because tangent uses opposite and adjacent. So this would be tangent of 62 equals O, which is x, over A, which is 25. Put this guy over 1, cross multiply. So I get x equals 25 times the tangent of 62. 47.0 is that side length. All right, next, circle my angle measure. This is adjacent, this is opposite. So tangent of 50 equals opposite over adjacent. Put this over 1. So I get 13 equals x times the tangent of 50. Divide everything by the tangent of 50. It cancels over here, so on my calculator I'm going to do 13 divided by tangent of 50. 10.9. So I get x equals 10.9. And one more on this page. Circle my angle measure. This is adjacent, this is opposite. So tangent again, tangent of 72, the angle measure we're talking about, equals O, which is x, over A, which is 36. Put that over 1, cross multiply. So I get x equals 36 times the tangent of 72. 110.8. Okay. Okay, so on these, they're wanting you to use tangent again, but they're just wanting you to show how our 45, 45, 90, and 30, 60, 90 triangles will give you the same output as if you were going to use the tangent ratios. So this is a 45, 45, 90 triangle. If I was going to use my special right triangles for that, this side would be 5 square roots of 2, because these two sides are congruent. If I'm showing that through SOHCAHTOA, so through TOA, tangent equals opposite over adjacent, opposite would be this 5 square roots of 2, and x would be adjacent. So I do tangent of 45 equals the 5 square roots of 2 over x. Put this over 1, cross multiply. I get x times the tangent of 45 equals 5 square roots of 2. So I'm going to divide by the tangent of 45 on both sides to get that x by itself. So I get 5 square roots of 2 divided by the tangent of 45. And I get 7.07. Well, if I put in my calculator 5 square roots of 2 and press enter, I get 7.07 also. So it'll give you the same answer. Here, this is a 30, 60, 90. To get from small to medium, you multiply by the square root of 3. So that would be 4 square roots of 3 times the square root of 3, which would be 4 square roots of 9. Square root of 9 is 3, so it would be 4 times 3, which is 12. So if I circle this guy, this is opposite, this is adjacent. So it would be tangent of 30 equals 4 square roots of 3 over x. Put this over 1, cross multiply. I get x times the tangent of 30 equals 4 square roots of 3. So I'm going to take 4 square roots of 3 and divide by tangent of 30. So 4 square roots of 3 divided by the tangent of 30. Now, you guys have to make sure when this is entered into your calculator, the 4 square roots will put an open parentheses. You have to put that closed parentheses there. So be careful on that and make sure to look at that. So that equals 12, just like what we said it would equal 12. And then it's going to work on this guy. So this went from small or medium to small, so we're going backwards. So we're going to divide by the square root of 3, so you just get 25 here. This is my angle measure. This is opposite. This is adjacent. So tangent of 60 is equal to 25 square roots of 3 over x. Put that over 1. Cross multiply. X times the tangent of 60 equals 25 square roots of 3. Divide by tangent of 60 on both sides. Enter that into the calculator, and I get x equals 25, which is what we proved it was earlier. So you can use either on some. The only ones you can't do those special right triangles, the only ones you can are the 45, 45, 90, and 30, 60, 90. Otherwise, you would have to use the tangent ratios. Find the area of the triangle. So area is base times height divided by 2, and base and height make a 90-degree angle. So this is a 40-degree angle. This is opposite. This is adjacent. So this would be tangent of 40 is equal to opposite over adjacent. Put this over 1. Cross multiply. Get x times the tangent of 40 equals 11. So I'm going to divide by the tangent of 40 on both sides. So 11 divided by the tangent of 40 is x equals 13.1. So now what I'm going to do to find the area is I'm going to do 11, the base, times the height, 13.1, because that's what makes the 90-degree angle. Divide by 2. So 13.1 times 11, divide that by 2. And I get 72.05. Same idea here. Area, so circle this guy. Actually, I'm going to pause on that one. I'm going to come down here. I'm going to show you how to do this one. This is x, this is opposite, this is adjacent. So I'm going to do tangent of 71 equals opposite over adjacent. Put this over 1. Cross multiply x times the tangent of 71 equals 34. Divide by tangent of 71. So 34 divided by tangent 71 equals x equals 11.7. Go ahead and try to finish this one and then check out the answer on the next video.